All right, Math 1 students. We move on from segments and we go to angles now. And basically, angles are formed by two rays that share or have the same endpoint. Okay? So when I look here, you have one ray here and you have another ray here. And they both share this common endpoint, W. Okay? Now, what you have to understand is the two rays make up the sides of the angle, and we call that shared endpoint, which is W. We call that the vertex of the angle. Now, angles are generally measured in what we call degrees. Okay, and the symbol we use when we name an angle is just a little angle symbol like that. Okay, now there are a couple different ways we can name angles. The first way we can name an angle is using, 3 points with the vertex in the middle. So when I look at this angle up here, if you wanted to trace this angle and not have to go over the same piece twice, how would I name this? I can name this V, I trace it to W, and I go to X. And if I look, my vertex is in the middle. So angle VWX would be a name of that. Now, notice I can go the other direction too. I can start at X, go to W, and go to V. So I could also name it XWV. The key to understand is your vertex is in the middle of both names. Now, anytime you have an angle and it's just one angle at a vertex, you can use the vertex to name an angle. This is only possible when there's only one angle at the vertex. So the angle up above, we can name angle W. Now, the last way, a lot of times you'll see this number or named this way, where you use the little number without a degree symbol inside the angle. So using a number, without a degree symbol. So this is sometimes possible, sometimes not possible. So keep that in mind, only if it's there. So here, if we had to name angle 1 using 3 points, I'm going to highlight angle 1. So this is the angle, Angle 1. So we can name that angle A, B, C. Now if I trace angle 2, that would be that angle, and I can name that angle CBD. Now remember, I can name those backwards too. Like for the first one, I could name CBA. I can name this one angle DBC. The key is both of them have a vertex at B, and you must name it with the vertex in the middle. So there are a few different types of angles that you guys will learn. The first one is an acute angle. And this is an angle whose measure is less than 90 degrees, So we basically say X can be greater than 0 or less than 90 degrees. So it's between 0 and 90 degrees. Now, what you have to understand is what a 90-degree angle is. Well, that's what you know as a right angle, A right angle is equal to 90 degrees, So X would just equal 90 degrees. We basically use a little box like that to show that it's a right angle or 90 degrees. Now, an obtuse angle is basically an angle whose measure is greater than 90 degrees. So we basically say X is greater than 90, but less than, you got to remember, if this line goes all the way down to make a straight line, less than 180 degrees. Okay? and then you have a straight angle. And a straight angle, right, is basically equal to exactly 180 degrees. So x would basically be 180 degrees. Now, when we measure angles, we usually measure angles in degrees. So as you see here, there is a protractor, and this is what we generally use to measure an angle. And with a protractor, you'll notice that in the middle, there's always a point. What you'll do is you take your vertex and line it up on that circle or point, and then you line up one side of the angle on the line that's here. Then you will basically see or extend the other side of the angle, and it would go through like that. Now, as an angle opens like this, right, all the top numbers represent the acute angles, right? So therefore, we would use the top numbers for a situation like this. If we extend and make it maybe a little bigger, like this, now it extends and the top numbers will represent your obtuse angle here. So right here, this would be 45 degrees, the red one. The blue one now would open up and be about 135 degrees. Now, just like that, you could also open angles the other way, where you have one side of the angle here, and then you have one side of the angle here. And if I look, now, when I look at this angle, does it look acute or obtuse? It looks acute. So what we're going to use is the bottom number for this angle. And then as we get bigger, you'll see the bottom number, right, would be your obtuse angle. So what it basically says is if the angle is eating to the left, you would use the top number. If your angle is eating to the right, you would use the bottom number. So if I looked at this here, how many degrees is this angle going to be? Well, if I look at this angle, does it look like it's more than 90 degrees or less than 90 degrees? It's less than 90 degrees, right? Therefore, we know if it's eating to the right, we use the bottom numbers. And if I guesstimate, it's 10, 20, 30, 40, 50, 60. Here's 70, so it's right in the middle of 60 and 70. So we're going to say 65 degrees. Okay. Now, if I look at this, right, determine the measure of this angle. So again, I look, here's my angle, here's one side of the angle, here's the other side of the angle. So it's between 50 and 60 degrees, right? So that angle would be 55 degrees. Now this angle here, right, if I look, if I highlight it, it's there, and it's here. So now as I go around this way, we're at 90, 100, 110, 120. So we're probably about 100 and I would say about 123 degrees. So this angle would be about 123 degrees. So now if we had to measure the following angles with a protractor, right? If you have one, you can go ahead and do it. If you don't have one, totally understand. So the angle addition postulate, right? If I look here, they're saying basically, if I take angle ABC, which is this angle here, and I add angle CBD, this angle here. When I add them together, it gives me one big angle, and that angle would be angle A, B, and D. Okay, so right away here, when I look at the diagram here, angle 1, if we had to name angle 1 using 3 points, that's this angle here. and we would name that angle APE. So angle APE. And again, the vertex always has to go in the middle. Now, if I add angle 2 and angle 3, that would be this angle here. And if I trace that angle, it would be here. And angle 2 plus angle 3 would be angle EPG. Okay. Now, letter C, right? Angle 6 plus angle 7 plus angle 1. 6, 7, and 1 is right here. Okay, and that's going to be angle NPE. So if I trace that, NPE. All right. So now, example 5, find the measure of angle ABC. If I look at angle ABC, what would I do with these two measures? Well, 45 plus, I would basically add 45 plus 60 to get 105 degrees. Okay. Now the next one, they're telling you this small angle is 20 and that big angle, right? They're telling you this whole angle is 160. We're basically saying 20 plus what would equal 160 degrees, right? Well, basically what I would do is go ahead and subtract 160 and 20 to get 140 degrees. All right. So, next one. Find the measure of angle DEF. Well, one, you should notice right away that this is a straight angle, or 60 plus 120 is 180 degrees. Okay, now, example 7, you know right away that this here is a straight angle. So if that's 110, right, and this whole angle is 180 degrees, I know that I'm going to do 180 minus 110, which is 70 degrees. Okay. Now, down here, example 8. What does this box tell us? This box tells us that that's a right angle, meaning this whole angle is 90 degrees. So we know what plus 40 would equal 90, or just do the big angle minus the little angle, and you would get 50 degrees. All right. Example 9. HID is 48 degrees, right? And remember, HID, what angle is it eating? That one. So that's 48 degrees. Then you have DIJ. That's this angle here. It's 120 degrees. So now, what would I do with those two angles to get this big angle? Well, 48 plus 120 would be 168 degrees. All right. Example 10. Angle ABC is a right angle. So right away what I'm going to do is put a box there. And I know that right away angle 1 plus angle 2 has to equal 90 degrees. So if angle 1 is 3x plus 4 plus angle 2 is x plus 6, when I add these two angles together, they have to equal 90 degrees. So in order for me to find the measure of angle 1, I have to find x first. So I'm going to go ahead and solve for it here. 4x plus 10 equals 90 degrees. I'm going to go ahead and subtract 10. 4x equals 80. Divide by 4, and x would equal 20. Okay, now once I know x, if angle 1 is what I'm looking for, and angle 1 is 3x plus 4, I know I'm going to do 3 times 20 plus 4, which is going to give me 64 degrees. Okay? All right. Example 11. They tell you angle ABC. So right away, angle ABC is 3x plus 8 degrees. So angle ABC is there. Then angle CBD is x plus 4. CBD. Now, when I take those two angles and put them together, how big is that whole angle? Well, if this is a straight line, you start the arc on this line, you end the arc on that line, it's going to be 180 degrees. So right away, what do these two angles have to add up to? Well, 3x plus 8 plus x plus 4 adds up to 180 degrees. So 4x plus 12 equals 180. 4x equals 168. When I divide by 4, right, 168 divided by 4 is 40. X is going to be 42. So right away, when it asks me to find the measure of angle ABC, right, that's that yellow angle. So angle ABC is 3 times 42 plus 8. Which gives you 134 degrees. Now, if I wanted to check my answer, if I plug x in here, that would be 46 degrees. And what should these add up to? They should add up to 180. All right. The next one. You're given the measure of angle MAR, right? And if I look, angle MAR, M-A-R, I trace it as I see it. It's this angle here. That angle is going to be 124 degrees. So right away, to find x, I know that I'm going to take these, add them together to give me that big angle. So I know angle MAC plus angle CAR add up to angle MAR. So 6x minus 11 plus 4x minus 25 equals 124 degrees. Combine like terms, 10x minus 36 equals 124. Add 36, you get 10x equals 160. Divide by 10, and x equals 16. If x is equal to 16, now to find angle MAC, right? 6 times 16 minus 11 would give you 85 degrees. Okay, so this should give you a good start on the notes, and I'll be there to answer questions later.